Programming instructors have diverse philosophies on how to best integrate AI into their courses. Some encourage it for personalized learning and industry preparation. Others restrict it or forbid it, worried about over-reliance and the challenge of detecting AI use. Regardless of their approach, understanding students' AI usage would be helpful for instructors. This helps them check whether AI use aligns with pedagogical goals, intervene early when spotting unproductive AI use, and establish effective policies for AI use. Prior work has used chat logs to show how students interact with AI, but chat logs alone does not reveal how students adapt or integrate AI suggestions. For example, we cannot tell whether they truly understand the concepts or if they are actively engaging with AI. The research gap aligned with what we found in a survey study with 27 programming instructors. First, instructors lack clear understanding. They often rely on manual checks and does not have direct evidence of learning. Second, tracking AI usage is hard. The problem-solving process is invisible, and there's wide variation in how students use AI. Third, AI policies are inconsistent. They vary by instructor and course, and simply binary rules like allowing or forbidding AI are insufficient and difficult to enforce. We introduced Editrail, a system that visualizes students' AI use in code edits, allowing instructors to monitor AI use and provide feedback. Editrail has two views, a timeline view and a code content view. Instructor can use Editrail to know how students use AI in their code and answer questions such as whether code is contributed by AI. The timeline view shows students' code edits in real time. The x-axis represents time from start to finish of coding. The y-axis represent code lines from the first line to the last line. Blue and orange marks show keystrokes, addition, and deletions. This allows instructors to quickly spot pauses, frequent edits, copy-paste, and unusual editing patterns. Editrail also highlights code that originates from AI. For example, when a student copies and pastes code directly from an AI message, the pasted lines are highlighted in red in the timeline. Second, when users accept autocomplete suggestions in the editor, the code is highlighted in green in timeline. Third, when a student retypes code that is very similar to what AI suggested, Editrail highlights it in light pink. By detecting these edits in the timeline, instructors can quickly identify AI-influenced code from various sources. We will show how it looks like in real time. The student starts from writing a welcome function on their own. The timeline background is in gray. Next, they copy-paste the function and the code line are highlighted in red in timeline. Then the student accepts autocomplete suggestion on the quicksort function with the code highlighted in green. In the end, the student writes a bubble sort function following what AI suggested. The code is highlighted in pink, showing it's similar to AI code but typed by students. When seeing a highlighted area in timeline, instructor may want to know whether the student understands this concept. They can click on any highlighted code in the timeline to create a targeted question. The system will then generate a targeted question specific to AI-generated code to help instructors check students' understanding. We ran a study with 12 participants, comparing Editrail with a baseline that only showed chat logs and code. We used real student data with samples ranging from 100 to 300 lines of code. With Editrail, instructors could identify distinct AI usage patterns. For instance, some students rely on AI at the beginning but worked independently later. Others accepted auto-completions but heavily edited the code, and some copied and pasted entire functions from AI outputs. Overall, participants were significantly more accurate in answering quiz questions using Editrail. In addition, our study revealed three key findings. Instructors could identify when and which student needed intervention. Chat logs give direct evidence of how students prompt AI, boosting instructors' confidence. The system opened opportunities for facilitating a feedback loop between instructors, students, and AI.